exciting to see the Army is looking forward instead of looking back. For decades, the concern was always that generals are fighting the last war. Technological innovation is usually what did we not have, and now there's the opportunity to look ahead and see what we need. I was asked to talk about our product and what challenge or tactical problem we would address, a proposed solution, and our innovative approach. If you indulge me, I'll take you on a brief staff ride, talk about World War I. Nearly 100 years ago today, the United States was faced with a world at war that they weren't involved in and beginning to plan for the eventual involvement in it. There was a lack of understanding and preparation for a key threat that resulted in tremendous casualties in the final Allied push, which was the Meuse-Argonne offensive. That campaign would become the largest military campaign to the date, involved 1.2 million men. Casualty count was almost 10%. Shows the shock to the military building up to that. Here's the spike in casualties. But these numbers don't reflect the very first battle of that campaign, and that was back here at home side. Spanish flu was a global pandemic that broke out between 1918 and 1919. There's various theories about where it originated, but there's a lot of evidence that shows that it originated here in the United States. The virus traveled from U.S. camp to camp in the prelude to the preparation for the Meuse-Argonne, as we were sending hundreds of thousands of troops over to Europe. It could very well have been called the Caldejon versus Spanish flu, because the outbreak was in U.S. camps first. It interfered with the induction and training, slowed the effort, sickened 20% to 40% of the U.S. Army and Navy, diverted urgently needed resources. Overall, the influenza and the resulting pneumonia that came from it killed more American soldiers and the seamen than the enemy weapons. Delafield Solutions, while I can't protect you from the influenza guaranteed, I can protect soldiers and workers from austere conditions. What we've done is offer a continuous area disinfection using a patented technology. It's safe and effective for occupied spaces. We provide both the technology and services to protect. Key points about our capability: the technology is matured and tested over 6 years in academia, industry, and defense venues. It's safe and effective. It can be installed in the HVAC systems or as modular systems. It's operational friendly. It runs all the time. No need for an operator or scheduling. And it's cost-effective. It's a cost-effective potential to decreasing one of the most challenging problems, health-acquired infections. What is our innovative approach? Basically, we do the same mechanism that's in your human lungs. We take the humidity that's in the air, run it through a catalyst, and create a temporary state of hydrogen peroxide molecules. As those hydrogen peroxide molecules go into the environment, they decompose back into water and oxygen, and that's the disinfecting process. They attack the microbes and bacteria that are in those spaces. There are minimal logistical requirements. Our main fuel is the humidity in the air. Low concentration effectively kills microbes without damage to the surroundings, the equipment in the space, or the people. While it's not encapsulated by water like the traditional brown bottle solution, it disperses easily, and it's highly effective because it doesn't have to fight its way out of the carrier, the water molecule. We release no additional chemicals or ozone, making it environmentally benign. There are existing hydrogen peroxide technologies out there. Where we are different is, as we said, we're not the liquid hydrogen peroxide that's placed in vaporized or misting solutions. We're not a harsh chemical treatment. We're not a foam. We're not ozone. We basically recreate what the human body does in its own lungs for its own immune system. Over those 6 years, we've done a number of independent laboratory results. Last year, we brought it to the field and put it in use in some practical applications. Our first case study was a Major League Baseball Player Development Center. We installed the system in a portion of their clubhouse to treat their minor leagues and their most commonly used areas. After spring training, the trainers reported back to us that it was their healthiest spring training in franchise history. They asked us to continue to treat the remaining part of the facility, and then we shared the story with the rest of the Professional Baseball Athletic Training Society in December of 2014. We also went to Commercial Maritime in the Galveston Bay. They had a mold problem that they were trying to eradicate. When they heard the effects that we had in the Player Development Center, they switched boats on us and said, we've got a boat that we dubbed the sick boat. They wanted us to treat that boat. We took it as a challenge because basically we described a working tugboat on the Intercoastal Canal as a floating porch, because a very porous working environment, 24/7, shared quarters. We wanted to see how well we would do in such a challenging environment. We were very close to what we saw in the baseball, and we saw some similar stories in contamination in those spaces and in the high use. In July, we started our first evaluation in a hospital, a cardiac telemetry ward that has, I believe, 33 beds. They're 80-90% occupied, a nursing staff of about 20 per shift, visitors and family that come in and visit. We received an investigational review board that approved it as a non-significant risk device. There was no consent required. It was blind to the cleaning crews, but the nurses knew that the systems were in place. The 4th month into the study, the anecdotal response from the nurses were, we perceive the rooms to be cleaner, we ourselves feel healthier, and we'd like to know when this device will be placed in the rest of the hospital. The study concluded in February. It's been submitted for publishment in the American Journal of Infection Control. It was accepted and awarded a award from one of the leading epidemiologists in the country for a new submission crediting this, the study and its process. There's some correlated impact on health-acquired infection rates that will be brought out in the 3rd phase of the study that will be included in the publication, and we'll be sharing that in July. Quick description, it can be deployed in 2 different applications, directly into the duct or as a modular system. Our next steps, product is ready for commercial market. Every trial has resulted in a sale. People who've used it have said, we like it, we're going to go ahead and buy it for the rest of our facility. We're seeking SBR opportunities with the U.S. military and Department of Homeland Security. And we're investigating partnerships with existing government contract holders to provide as a component as a kitted solution. I'm here in Huntsville, and beat Navy. The OSHA requirements are based on the misting or aqueous solutions, but we've chose to follow those, even though as a dry gas, we have less concentrations to the human body. The human body will produce more hydrogen peroxide in your lungs than what we're producing. The difference is that we're continuous. And the major answer to that is that we've had 3 investigational review boards. We've done a toxicity study against mammals, no long-term ill effects, and the investigational review board basically said that it is safe as any other known disinfectant. It doesn't require informed consent for the people working in spaces.
Okay, thank you.